In this video, we're going to take a look at how to use the definition of the derivative, how to apply it, and then how to work with some of the interesting cases that you'll see when encountering the definition of the derivative and finding the derivative of a function. So let's take a look at our first problem. So find f prime of x of 1 over x using our formula here. So where should we start? So when I'm doing problems like this, it's basically just plug and chug. So we're trying to find the derivative, so make sure you put your f prime of x is equal to, remember your limit as h approaches 0 of. So when you get to here, you have to think, what am I doing for this first step? F of x plus h. Essentially, we're substituting this x plus h into wherever x is in our function. So this would be 1 over x plus h. Now we're subtracting. If you take a look here, we're subtracting the original function, so just 1 over x. Then we're also going to be dividing everything by h. So once we get to here, what I would do is, because this numerator looks messy, so what I would do is I would multiply each side by each other's denominator, essentially to get a common denominator so we can subtract. So this would be the limit as h approaches 0 of x over x, times x plus h minus x plus h over x times x plus h. Right? And then, of course, that's going to be divided by h. So from here, essentially, you can subtract the numerator, not the whole numerator. And well, it is the whole numerator, but specifically this top numerator. I'll circle it in yellow. And that's good, because you'll notice x minus x plus h. We have to distribute that negative, but these x's will cancel, which is perfect. And that's really what you want to look for in these problems. What can cancel? So this now equals the limit as h approaches 0 of, now bear with me here, x minus h all over x times x plus h over h. Okay, now like I said, look at this. We now have, since these x minus x, we now have negative h over x plus h all over h. Now from here, you're like, well, what do I do from here? I mean, if I substitute, I'd get 0 over something over 0. That would be undefined. That wouldn't work. So we're going to go a little farther. And looking at this, I would consider this h over 1. Why? Because at this point, you can multiply. And what do I mean by that? This would be h over 1. So take the reciprocal of the base of the fraction. If there's two fractions, if there's a fraction over a fraction, you can multiply the top fraction by the reciprocal of the bottom fraction. So let's do that. The limit as h approaches 0 of negative h over x times x plus h times, that'd be 1 over h. Now something interesting happens here. These h's will cancel. So don't even worry about those. And that's perfect. You want stuff to cancel. That's what makes these problems much easier. So now we have the limit as h approaches 0 of, looks like just negative 1 over x times x plus h And then at this point, you can substitute because it won't be 0 over 0 anymore. So that would equal -1 over x times x plus 0. Or once you multiply that out, that'd be -1 over x squared. And there you go. There's your derivative of 1 over x. So let's move on to another problem. All right, so find the derivative of 2x squared plus 3x minus 2. So again, what are we doing here? We're just substituting this for these two x's. So our function, or excuse me, our derivative is equal to the limit as x, excuse me, not x, h approaches 0 of, now this is where you got to be careful, and with quadratics and above, like this, things can get a little messy. So what do we have here? We've got 2 times x plus h squared plus 3 times x plus h minus 2, and then we're going to subtract the whole function. So 2x squared plus 3x minus 2. That's, of course, all over h. So essentially, from here, we have to clean up the numerator. So let's change colors. Equals the limit as h approaches 0. Of course, remember your limit notation every time you're writing this until you actually take the limit. And also, I want to note, this is just something I think you should memorize. X plus h squared, because this comes up quite a bit when doing the definition of the derivative, is x squared plus 2xh plus h squared. Of course, you could FOIL it out, but when you're doing these problems on an exam or a quiz, it's much faster when you have that memorized, or at least written off to the side, when you're doing, pretty long problems similar to this one, or maybe longer. So we have 2 times x squared plus 2xh plus h squared plus, and then of course we're going to distribute that 3. That'd be 3x plus 3h minus 2. And then, of course, when we have this negative outside of a parentheses, we're distributing that to everything. So it'd be minus 2x squared minus 3x plus 2. Of course, that's all over h. So now from here, we only have to clean up this parentheses over here with the 2. So that would equal the limit as h approaches 0 of 2x squared plus 4xh plus 2h squared plus 3x plus 3h minus 2 minus 2x squared minus 3x plus 2 all over h. Now when you get to this step where everything's kind of factored and FOILed out and everything, you really want to look for things that cancel. And if you did the problem right, there's going to be a lot of things that cancel. So what I'm looking at right now, there's a negative 2x squared. Let's get rid of that. And there's a 2x squared. There is a 2 over here, plus 2, and there's a minus 2 right there. There's a 3x. There's a minus 3x. We basically only have variables here, or multiple variables together, that include h. And that's something you want to see with problems like this. So let's simplify. So the limit as h approaches 0 of 2h squared plus 3h plus 4xh all over h. And now when you look at this, typically when you're doing problems like this, you're going to notice that an h is going to end up in each of your expressions here in the numerator, and that's great. You really want to see that because you can use that to your advantage. Limit as h approaches 0. So this will be, you're going to factor that h out. That'll just be h times 2h plus 3 plus 4x all over h. And look at that. Here we can cancel out the h and keep going. And essentially we can substitute in now because it won't, the denominator won't be 0. So that'll just be equals, let's see, 2 times 0 is 0. And then looks like there's no variable next to 3, so that's just 3. So equals 3. And then that's just 4x. There's no h, so plus 4x. So for this function up here, 2x squared plus 3x minus 2, we found that f prime of x of this function is equal to, or the derivative is equal to 4x plus 3. So that's essentially how to do the definition of the derivative. It takes a little practice, but I swear you'll get it. So good luck in your calculus classes, and I'll see you guys next time.